Good evening, everyone. I voice the title, ma'am. Hello.
Hi, sir.
Okay. Masigi anishuba numitigi akoina science and environment gi magi portion amada oina akoina physics ki portion din nainagani. Akoina physics ki tongan ba magi tongana branch leijata argasu akoina sida khara khangalaga haitare topic khara khangalakanda hariba topic singa je nainagani ko sigi physical quantities fundamental and derived units aduga magi dimensional formulasing adui motion force and laws of motion work energy and power adudagi step heat and temperature sound optics and some physical related inventions and discovery aduga important scientific instruments ko haibajing je akhoi ngasi class da nainagani ahan topic ta akhoi physical quantities ko si lakching on the physics hai taragadi akoina khangba yaise physics hai taragadi physics is the branch of science which deals with the study of nature and properties of matter and energy ko magi nature amsung properties of mag leiba kamaina sai adudai karamaina tawi haibado adu mangonda leiba energy jingdui maramda leina physics laire the science the subject matter of physics include heat, light, sound, electricity, magnetism, and structure of atoms. Ko. Sumai tawdana akoina physics akoina applied physics haraga suma lei sina application of the physics to help human beings and solving their problems. Ko. Sida akoina the physics and engineering siga mari leinabajina akoina applied physics hai kangai aduga akoigi topic ta physical quantities. Physical quantities hai taragadi akoina all quantities in terms of which laws of physics can be expressed in which can be measured are called physical quantities ko sumai tawdana akoina physical length onba yaba hai tare leiba any measure tawga yaba pot adudagidi tongan sida mass time pressure temperature current and resistance are considered as physical quantity magi chang onba yaba concrete oina leiba jingje chang oina onba yaba jingje akoina physical quantity sai khangnai aduga sida classification of physical quantities ta akoina ani thongna lei fundamental quantities haiba or base quantities haiba aduga amana derived quantities fundamental dagi akoina punjalagan semba maina tawba derived quantities haisina fundamental jingda leiba quantities jingdai punjalaga semba derived quantities ko the sida fundamental quantities that are the physical quantities that are independent to each other are called fundamental quantities aduga derived quantities haigana all the other quantities which can be expressed in terms of fundamental quantities are called derived quantities ko sumana sal quantities leiba ki akoina sida unit moi leiba on be yaba quantity jingdugi magi tongan masagi unit leijeba fixed physical quantity sida unit hai tardi the non-fixed physical quantity is called unit co or the quantity used for standard or for measurement is called unit the quantity used for standard when is one of the sinariba quantity akoina unit hai khangnai magi sida tongan unit ki properties khara pili unit should be some suitable size haibadi akoina akaknaba mayam sinaba yaba oigadawni must be well defined oigadawni should be easily reproducible adudagi unit must not change with time unit should not change the physical condition like temperature pressure etc and the unit must be easily comparable experimentally with similar physical quantities magi properties ni ko unit ke kone unit ngasai classification of unit ko unit sida ngasai kone fundamental quantities like you do adugi fundamental unit le ba ꯑꯗꯨ ꯂꯥꯛꯇ꯭ꯔꯤꯉꯩ ꯃꯃꯥꯡꯗ ꯁꯤꯁꯇꯦꯝ ꯑꯣꯐ ꯌꯨꯅꯤꯠ ꯍꯥꯏꯇꯥꯔꯒꯗꯤ ꯉꯁꯥꯏꯒꯤ ꯁꯤꯁꯇꯦꯝꯁꯤꯡꯗꯣ ꯑꯩꯈꯣꯏꯅ ꯆꯠꯅꯕ ꯁꯤꯁꯇꯦꯝ ꯃꯈꯜ ꯈꯔ ꯂꯩ ꯁꯤꯗ ꯁꯦꯟꯇꯤꯃꯤꯇꯔ ꯒ꯭ꯔꯥꯝ ꯁꯦꯀꯦꯟ ꯑꯗꯨꯃꯥꯏꯅ ꯁꯤꯗ ꯐꯤꯠ ꯄꯥꯎꯟ ꯁꯦꯀꯦꯟ ꯁꯨꯃꯥꯏꯅ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ ꯃꯈꯜꯁꯤꯡ ꯂꯩ ꯁꯤꯗ ꯑꯩꯈꯣꯏꯅ ꯑꯍꯥꯟꯕꯗ CGS system haitaradi in the system the unit of length is centimeter, the length and the unit of mass is gram and the unit of time is second. Sumaina tawduna CGS system sida magi unit oriba quantity je akoina centimeter gram amasung second neba. Sumaina tawduna sigi FPS system haitaradi sidana foot pound and second oiba MKS dana length dana meter oire magi unit of mass dana kg oire aduga unit of time dana second oire. So SI system international standard unit tuna yeah that's correct. Hꯧꯖꯤꯛ ꯈꯤꯇꯪ ꯅꯨꯡꯉꯥꯏꯇꯕꯒꯤ ꯆꯠꯂꯨꯕ ꯃꯥꯜꯂꯤꯀꯣ ꯁ꯭ꯀ꯭ꯔꯤꯟ ꯁꯤꯌꯔ ꯇꯧꯕꯁꯤ ꯎꯏꯀꯣ ꯃꯌꯥꯝ
Ore sir.
sida SI unit ꯂꯩꯔꯦ SI unit system sida magi sidana MKS mathakta piriba MKS length na meter oiba mass na kg oiba du time na second oiba sibu akoina SI unit system da sigi haiba unit sing sinaganeba aduga fundamental units laida length mass time temperature current electric current luminous the intensity sina my quantity to the length na meter mass na kilogram time na second sumain to my symbol sing laida aduga supplementary unit na mu angle plane angle radian laida solid angle straight radian laida aduga advantages of SI unit one magi advantages laida SI unit system ke so it is a cohesive system of unit the derived system unit of the derived unit of a physical quantities are easily obtained by multiplication or division of the fundamental units score. It is the resonant system of unit. It uses only one unit for one physical quantity. Example sida joule haibadi akoina any form of unit ama semga oi hanba matamda majina standard apunbana ohanbe yaba amasung hariba atopa unit sing nataba sigi leiriba SI unit sida yauriba magi fundamental units amasung supplementary unit sing je punjala kanda magi standard unit ama semba yaba masin marmar kanda kona SI unit se mapung oina sinari neba tonga tonga mai definition sing leire se adum akhoni yengjalakan adum par kan yani ko semadi then ngasagi SI unit sing to dimension formula ko so the dimension is the powers to which the fundamental unit of mass length and time written as MLT arise which include their nature and not their magnitude ko sida piriba dimension hai taragadi ngasagi any fundamental unit to gi lairiba mass length natragana time adu to gi mangonda power when kari dubo kona sigi dimension formula hairkatweneba dimensional formula sida makada leire speed sida n expression along with power of mass, length and time which indicates how physical quantity depends upon fundamental physical quantity ko. Example speed leire. Speed haiba sigi formula se puthokpa matamda distance leire distance te akoina length only and time na second only aduna sida magi sida dimensional formula no ngasai lmt sida magi power karakpa du akoina dimensional formula haiduneba aduga sida tongan ba dimensional formula sing leire force kina mass into acceleration mass ta smain tawdana magi dimensional formula amasung magi SI unit ko sisingse adum akoina exam point of view da si je adum akoina pasanba yai singba je adum hangpa yai tongan ba leiba magi physical quantities natragana SI unit natraga dimensional formula jingje mari leina na haitare question je si tongan ba magi makhan sida mayam leire sisingse adum akoina yingjanba yai. Next topic the force and motion. The motion item in physics, motion is the change of position of an object with respect to its surrounding in a given interval of time. Change of position haidune motion haitari with its surrounding with a given interval of time oigdaba matamga matungina mana position change tawbra tawdabra haibdo adugi dubo khoina motion hair kangnai adu lakti mamang sida scalar and vector quantities ko. Scalar quantities are those quantities which have only magnitude but not direction. Only magnitude dang laiba. Haidi mai value dang laiba direction yaudabadu akoina scalar quantity to vector quantity haigana vector quantities are those quantities which have both magnitude as well as direction. Direction yauba masumagi value malai leijabadu aduna vector quantities ko. Sumaina tawdana tongan ba types of vector quantities lay mana direction rapanina maram akanda sida negative vector sairapa karigumba magnitude tuga man chaliba direction tuga khena tagari akoi na madubu negative vectors equal vectors haigana direction do magnitude and direction do same oita gadi equal vector unit vector haigana the vector divided by its magnitude is called a unit vector ko. It has a magnitude of 1 unit and 1 direction, same as the direction of the vector. Collinear vector. Two or more vectors having equal and unequal magnitude but having the same directions are called collinear vectors. And zero vector having zero magnitude and direction, arbitrary direction over. Not to be fixed, it is called zero vector. Zero vector na denote tawise o na denote tawi. Maya tawna masagi motion ga mari leinaba tam jingkar piri sida distance hai taragadi distance is a scalar quantity. Scalar quantity hai taragadi ngasai only magi kano numerical number amta leiba aduga magi direction yaudabaduna distance leire. Displacement has the shortest distance between 2 points is called displacement. It is a vector quantity. Anisi khenaba amana vector scalar quantity oiba distance na aduga displacement na vector quantity oiba. Speed and rate of change of direction is called speed. Speed se magi scalar quantity ni magi unit na meter per second. Aduga velocity haigana that time rate of change of displacement. Ngasagi asida somna kanda leiba displacement je sigi time change with time odone magi leiba magi time duga mana hongba jang dugi velocity speed hot pa dubu akoina velocity har khangnai magi unit of velocity na meter per second and dimensional formula na m0 l1 t inverse 1 inverse oiba and the acceleration, the change in velocity per unit time, the time rate of change of velocity ko acceleration hai taragadi velocity to the cam my velocity rate of change of displacement to the time divide to acceleration aduga sida acceleration je positive oi hai taragadi velocity do hengala taragadi maje positive acceleration se positive oi hai gani aduga negative oirgana retardation hai gani magi unit sing leire si ngasai gi table du da adum yawrabni ko si jima si unit sing adu dimensional formula sing ja force hai taragadi force is an agent that produce acceleration in the body on which it acts, or it is a pull or push which changes or tends to change the position of a body at rest or in uniform motion ko lengaga leiba bo natragana karingba lengana leiba pot ama mangonda illa kanda external force ama pira kanda ma du lenghanba natragana lephanba adu dubo koina aduda tawriba agent hai tare mangonda pisaliba karam safu du koina force hai khangne force a vector quantity ni magi SI unit na newton sida tongan ba type of force ta lere contact force hai bam ko sina akhoi na ngasagi mangonda pisaliba force je kamai tawdun pisan ba ma masama potuga akhoi na thengnara kanda chapchan thengnara kanda pisan ba du contact force aduga non contact force hai kana thengnadraga ju safu ma piri budna non contact force ko gravitational force and the electrical magnetic force and types of the fundamental force like gravitational electromagnetic strong nuclear weak nuclear is na fundamental force I don't know laws of motion Newton's law of motion ko Newton na putong law hum le it first kana it states that everybody continues in its state of rest or uniform in a straight line until some external force is applied on it. Aduga ma akhona Newton first law je law of inertia hairga gangnai ko. Example when akhona a book lying on a table will not move at its own. It does not change its position from the state of rest until no external force is applied on it. Sina Newton's first law. Second law dana kai hai kanda the rate of change of momentum of a body is directly proportional to the applied force and the change takes place in the direction of the force applied or acceleration produced in a body is directly proportional to force applied. Sina second law. Second law na haisina ngasagi body ma rate of change of momentum sum honga chatpado adu the inversely or directly proportional to the applied force mangonda kaingba lefan ge natragana chalan ge hai ta gadi ngasagi in directly proportional oi haiba Newton third law hairgana to every action there is an equal and opposite reaction or action and reaction are equal and opposite sina Newton ki third law sina momentum hai tardi the quantity of motion contained in the body is linear momentum ko sagi posak ama any body amada mangonda lengaga leiba posak ama do kaidoba adum magi lengaga adum leiba magi cha natragana lepa leiba po ma adum lepa leiba do adu bokona momentum hai kangai for example a fast moving cricket ball has more momentum in it than a slow moving 1 ko mongoda leiriba manungi leiriba energy do haitare adubu dynamic momentum ko gravitation agan si tamni gravitation or gravity is the force of attraction between two bodies ko gravitation or gravity hai tari pot ani ki marakta leinariba magi chingchanabagi force shakti dubu akoina gravitation lei aduga magi SI unit na G ko gravitation adum wari aduga magina Newton meter square kilo aduga kg inverse 2 oiba low gravitation states that the force of attraction between two objects is proportional to the product of their mass and inversely proportional to the square of the distance between them. And the law applies to objects anywhere in the universe. Such a law is said to be universal. Gravitation force हाइबसे अखोई universe ते लेइबा पोषक खुदिमक्ता gravitation से लई अदुना अखोइना सिजिबु universal law हाइरगा अखोइना हाइबे याइ अदुगा सिदा अखोइना work power and energy को work is said to be done when the force applied on a body displaces it through certain distance in direction of applied force ko koina work ama tawe hai ta agar is said to be magi force ama pichal lakanda kaimba pot sak to lengba natrana mafam ko mata agadi akoina madu bo koina work ama taw ko hai kangni aduga mana sida work ki SI unit leire work ki SI unit si joule loe matuka my dimension formula ko energy of a body is defined as the capacity of the body to do the work asagi sida work ama taw bai base akoina force amsu displacement ne bada ga oi sigi ani je taw matamda akoina energy masa du da leiriba manung du da yaw magi energy do adubuna thabak to tawnaba ngamnaba one of the mongonda yawriba shakti tu bo akoina energy leire energy na scalar quantity oiba maju SI unit se zum joule oi kinetic energy and energy possessed by the body by virtue of its motion is called kinetic energy akoina lenga kanda puthorapa makhalgi energy dubu akoina kinetic energy kawe example oina sida running water natra wind energy or walk on the kinetic or moving bullet ko sina man puthorapa leng gamatung inna mangondagi tholaiba energy makhal du kinetic energy potential energy agna energy possessed by the body by virtue of its position leng dana leiraga su kaimba posaktuna mai manung du da yawriba energy tungjal laga leita adi madu na koina potential energy loss of energy da koina magi statement da kai hairaga energy can neither be created nor be destroyed but can be converted from one form to another ko energy je form amadagi amada magi convert away haba and power hai kagari power is defined as the rate of work done in rate at which work is done by a force ama pishalakanda thaba ma tawre aduda tawriba dubo khoina power hai ne the work done per unit time is also called power kai ma thaba ma tawre adu matam per unit time matam akana matam amda kyam thabak tawre habjibo khoina power hai gani aduga magi SI unit na watt aduga dimension formula na m to the power 1 L2 and T to the power inverse 3 ko smai taw da si khon nei nei jing tam jing na ya mani ko duga khon heat and temperature ko heat is the form of energy which produce the sensation of warmth or coolness asagi energy ꯀꯔꯤꯒꯨꯝꯕ ꯕꯣꯗꯤ ꯑꯃꯗ ꯂꯩꯔꯤꯕ ꯃꯥꯒꯤ ꯃꯅꯨꯡꯗ ꯌꯥꯎꯔꯤꯕ ꯀꯔꯤꯒꯨꯝꯕ ꯑꯃ ꯇꯧꯕ ꯉꯝꯕꯒꯤ ꯀꯦꯄꯥꯁꯤꯇꯤꯗꯣ ꯑꯗꯨꯗꯨꯕꯨ ꯑꯩꯈꯣꯏꯅ ꯏꯅꯔꯖꯤ ꯍꯥꯏ ꯑꯗꯨꯗꯣ ꯏꯟ ꯗ ꯐꯣꯔꯝ ꯑꯣꯐ ꯁꯦꯟꯁꯦꯁꯟ ꯑꯣꯐ ꯋꯥꯔꯝ ꯑꯦꯟ ꯀꯨꯜ ꯀꯔꯤꯒꯨꯝꯕ ꯏꯪꯕ ꯅꯠꯇ꯭ꯔ ꯁꯥꯕ ꯑꯗꯨꯒꯤ ꯃꯈꯜꯒꯤ ꯐꯥꯎꯍꯟꯕ ꯉꯝꯕꯗꯨꯕꯨ ꯑꯩꯈꯣꯏꯅ ꯏꯅꯔꯖꯤ ꯍꯥꯏꯔ ꯈꯪꯅꯩ SI unit of energy is joule ko sisu heat energy je joule da my SI unit joule hoy and temperature is the degree of hotness of the body ko temperature hai taragadi degree of kaimba posa amagi magi sabagi chang du ko temperature hai kangnai and the unit of temperature je ko na tuan ba makal da lai hare ngarang ki class da ju याग्रबन सुमाना फेरेनहाइट सेल्सियस डिग्री एंड केल्विन हारिबा सिग्रिजम कन्वर्सन जे अमांग एग्जाम दसु हंग्रबनी को टेम्परेचर का मरी लेना कोना ट्रांसफर ऑफ हीट से कोना ट्रांसफर तो बे कमाइन तो बे तारगदी कोना सिदा कंडक्शन है तारगदी इट इज डिफाइंड एज द मोड ऑफ ट्रांसफर ऑफ हीट इन व्हिच द हीट ट्रेवल्स फ्रॉम पार्टिकल टू पार्टिकल इन कांटेक्ट हाइबदी कोना पोषक एनी पोट थेंगनर मतुंगदा मदुदगी हीट तो ट्रांसफर तौता एनर्जी दो ट्रांसफर तौता मदुना कंडक्शन कन्वेक्शन है the process of transmission of heat in which heat is transferred from one point to another by the physical movement of the heated particle is called convection ko जगह कम सागला पार्टिकल फिजिकल मूवमेंट तौरकान मफम चलकान हिट हिट अप तौखलपदो तोान तोान पार्टिकल लेरम हाँ लेरम मफम चेंज तौरकान मफम सारकान लेबदो कन्वेक्शन रेडिएशन है द प्रोसेस ऑफ हीट ट्रांसफर इन व्हिच हीट इज ट्रांसपोर्टेड फ्रॉम वन प्लेस टू अनदर विदाउट heating in the intervening medium is called radiation. Radiation है ताकना heat से transfer तो हुआ without any medium को कोई sunlight light से example वही ना सिंबल सिंग से अपन radiation की मनुष्य चले आगे heat transfer की the difference between heat and temperature period जाएगी मागी SI unit अमसुम के SI unit खेनाबा अदे मागी काइनेटिक एनर्जी खेनाबा को and this is web motion and its application को web है ताकि निकासागी it is the disturbance in which energy is transferred from one point to another due to the repeated periodic motion of particle of the medium है बने periodic movement वही ना कोई ना मागी ट्रांसफर ऑफ एनर्जी दो पेरियोडिकल ओइबा मजुंग मागी वेब ओइना जता करी मदु बोना ए वेब हाइड्रोनेबो पेरियोडिक मोशन ओइना जता गदी होना वेब से मखदानी थोंग लई मैकेनिकल और इलास्टिक वेब एंड इलेक्ट्रोमैग्नेटिक वेव्स को मैकेनिकल वेव्स ता those waves which are produced due to the repeated periodic movement of the medium particles are called mechanical or elastic waves. They need a material medium for which generation and propagation. Mechanical wave tadi akoina moije repeated when magi motion je produce toragadi akoina mechanical wave haire adu moina medium darkar leeba moina hojiki energy je transfer to matamda si buna mechanical wave aduga electromagnetic wave haire taragadi light without any medium the moina transfer of heat natra energy dubu koina without any medium the chalan baduna koina electromagnetic wave ko the types of wave motion ko wave motion le koina ani tong lei transverse wave motion having a longitudinal wave motion. Transverse wave motion that is when the particle of the medium vibrates perpendicular to the direction of propagation of the wave. The wave motion is called transverse wave motion. sida sida piriba figure sida ngasai wave se perpendicular oina magi direction duga mana chaliba direction of disturbance natragana akoina chaliba magi motion do aduduga perpendicular oina chatagadi sina sibo koina transverse wave har khangnei ko aduga the distance between the two consecutive crest and trough hai taragadi koina any sigi piribasida sida tongkhatpa sarusina crest sida tongkhatpa sarusina crest lere aduga sigi magi makhada chalibasina trough sina transverse wave kawe aduga longitudinal wave hai taragadi when the particle or medium vibrates parallel to the direction of propagation of wave the wave motion is called longitudinal wave motion sida particle mangonda yauriba wave tuna chaliba gi direction duga kemo mana moina wave tuna propagate tawriba direction duga mana taragadi aduna longitudinal wave motion ega main sida the main difference between transverse and longitudinal wave are aga sida ahanbadana direction of propagation of wave to amadana perpendicular oin chatkani amadana parallel oin chatkani ba koina sigi figure sida ubu phangi ko amana perpendicular oina crest trough le chatpa amadana direct direction of wave tuga direction of particle motion duga chap manana chatpado aduna parallel oiba ko sumana transverse wave and longitudinal wave leire aduga sida koina tonganba magi wave na chatpa matamda leiba tonganba magi termsing the displacement height the distance of a particle from its mean position at any instant is called displacement ko ngasai chaliba samana ngasai mamang da su motion gi yaw du ga samana re sigi wave ta ngasai any particle amna leiramba dagi mana jaga amadagi homudo amafam de homudo displacement lere aduga amplitude hagan it is the maximum displacement of the particle from its mean position of rest lengda leiramba point tagi mana chalakanda maximum kyam sangna chatpa ngamba ge habaduna one amplitude ko adu wave length hagan it is the distance traveled by the wave in the time in which the particle of the medium completes one vibration. When one vibration ama tawbu matamda amuktang mana chatpa matamda mana yam sangna chatpa travel by the wave in the time in which the particle of the medium completes one vibration ko kyam masing kyarak chatpa ngambagi habagi aduduna wavelength. It is denoted by lambda ko wavelength je koina represent kain taw hakan lambda na time period hakan it is defined as the time taken by a wave to complete one vibration or one cycle sida ngasai one vibration or one cycle wavelength duna natraga sida leiriba hoigi wave motion da jaga amadagi lengda leiramba dagi mafam amda homu matamda changiba magi punba crest and trough tubu adu changiba matamdu koina time period haiduneba frequency the number of vibration made by a wave in 1 second is called frequency ngasagi second amada kyam yamna wave lemana kyam madu kyara kaba kumba tawge habduna hoina second amada kyam kaba kumba tawge habduna frequency aduga magi unit sina hertz kilohertz natraga megahertz singusida pieba aduga wave velocity haigadi the distance traveled by the wave per unit time is defined as a wave velocity aduga electromagnetic spectrum haitagadi an electromagnetic spectrum is the entire range of all types of electromagnetic radiation ko electromagnetic spectrum akoina sunlight sidagi source of light energy ꯑꯣꯏꯔꯤꯕ sunlightꯗꯒꯤ ꯃꯉꯣꯟꯗꯒꯤ ꯊꯥꯗꯣꯔꯛꯄ energy ꯃꯈꯜꯗꯨꯕꯨ ꯑꯩꯈꯣꯏꯅ ꯁꯤꯒꯤ electromagnetic spectrum ꯍꯥꯏ ꯁꯤꯗ ꯃꯥꯅ ꯀꯩ ꯌꯥꯎꯏ ꯍꯥꯏ ꯇꯥꯔꯒ frequency wavelength and energy ꯀꯣ ꯍꯥꯏꯔꯤꯕꯁꯤꯡ ꯑꯁꯤ ꯉꯁꯥꯏꯒꯤ ꯋꯦꯕꯁꯤꯗ ꯌꯥꯎꯔꯛꯄ ꯃꯥꯒꯤ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ ꯃꯥꯏ ꯃꯑꯣꯡꯁꯤꯡꯗꯨꯅꯦꯕ it expands from long wavelength ꯁꯥꯡꯕ or low energy radio waves to short wavelengths ꯀꯣ high energy gamma rays including the narrow band of the visible light ꯁꯨꯃꯥꯏꯅ ꯇꯧꯗꯅ electromagnetic spectrum ꯁꯤꯗ ꯑꯩꯈꯣꯏꯅ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ electromagnetic spectrumꯗ wavelength ꯇꯣꯉꯥꯟꯕꯒꯤ ꯃꯇꯨꯡ ꯏꯟꯅ ꯑꯩꯈꯣꯏ energy ꯇꯣꯉꯥꯟꯕꯒꯤ ꯃꯇꯨꯡ ꯏꯟꯅ wavelength ꯇꯣꯉꯥꯟꯕ ꯂꯩ ꯑꯗꯨꯗꯒꯤ energy ꯋꯥꯡꯉꯒꯅ ꯀꯃꯥꯏꯅ ꯇꯧꯒꯦ ꯍꯥꯏꯕꯗꯣ ꯑꯩꯈꯣꯏꯅ ꯁꯤꯗ ꯁꯤꯒꯤ ꯃꯈꯥꯗ ꯄꯤꯔꯤꯕ ꯗꯥꯏꯒ꯭ꯔꯥꯝꯁꯤꯗ ꯑꯗꯨꯝ ꯅꯩꯅꯕ ꯌꯥꯏꯀꯣ ꯑꯩꯈꯣꯏꯅ ꯁꯤꯗ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ ꯃꯥꯒꯤ wavelength ꯑꯃꯁꯨꯡ frequency ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕꯒꯤ ꯃꯇꯨꯡ ꯏꯟꯅ ꯑꯩꯈꯣꯏꯅ ꯁꯤꯗ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ ꯃꯥꯒꯤ waves ꯃꯈꯜ ꯂꯩꯔꯦ radio wave ꯍꯥꯏꯇꯥꯔꯒꯗꯤ longest wavelength ꯑꯣꯏꯕ ꯑꯗꯨꯒ ꯃꯤꯇꯔ ꯇꯨ ꯀꯤꯂꯣꯃꯤꯇꯔ ꯃꯥꯒꯤ ꯀꯩꯅꯣꯁꯦ ꯑꯣꯏꯕ ꯌꯥꯏ used in radio ꯅꯠꯇ꯭ꯔꯒ TV and mobile phone communication ꯀꯣ microwave used in cooking microwave oven and radar ꯁꯨꯃꯥꯏꯅ ꯇꯧꯗꯅ ꯑꯩꯈꯣꯏꯅ ꯈ꯭ꯋꯥꯏꯗꯒꯤ longest wavelength ꯁꯤꯅ ꯔꯦꯗꯤꯑꯣꯒꯤ ꯋꯦꯕꯁꯦ ꯑꯣꯏꯗꯣꯏꯕ ꯑꯩꯈꯣꯏꯅ ꯔꯦꯗꯤꯑꯣ ꯇ꯭ꯔꯥꯟꯁꯃꯤꯠ ꯇꯧꯔꯤꯕ ꯋꯦꯕꯁꯦ ꯑꯗꯨꯒ ꯁꯣꯔꯇꯦꯁ ꯋꯦꯕꯂꯦꯡꯅ ꯑꯩꯈꯣꯏꯒꯤ ꯔꯥꯏꯠꯇ ꯂꯩꯔꯤꯕ ꯁꯣꯝꯒꯤ ꯒꯃꯥ ꯔꯦꯁ ꯍꯥꯏꯔꯤꯕꯁꯦ ꯁꯤꯁꯤꯕꯨ ꯑꯩꯈꯣꯏꯅ ꯁꯤꯅ ꯁꯣꯝꯒꯤ ꯁꯔꯨꯛꯁꯤꯅ ꯁꯣꯔꯇꯦꯁ ꯋꯦꯕꯂꯦꯡ ꯑꯣꯏꯗꯣꯏꯕ ꯑꯗꯨꯗꯒꯤ ꯏꯅꯔꯖꯤ ꯂꯦꯚꯦꯜꯗ ꯌꯦꯡ ꯇꯥꯔꯒꯗꯤ ꯑꯩꯈꯣꯏꯅ ꯃꯥꯒꯤ ꯐ꯭ꯔꯤꯀ꯭ꯋꯦꯟꯁꯤꯁꯦ ꯔꯦꯗꯤꯑꯣ ꯋꯦꯕꯇ ꯂꯩꯔꯤꯕ ꯐ꯭ꯔꯤꯀ꯭ꯋꯦꯟꯁꯤꯁꯦ ꯂꯣꯋꯔ ꯋꯦꯕ ꯐ꯭ꯔꯤꯀ꯭ꯋꯦꯟꯁꯤ ꯑꯣꯏ ꯑꯃꯁꯨꯡ ꯂꯣꯋꯔ ꯏꯅꯔꯖꯤ ꯑꯣꯏꯌꯦꯕ ꯑꯗꯨꯒ ꯀꯔꯤꯒꯨꯝꯕ ꯃꯥꯅ ꯂꯣꯋꯔ ꯏꯅꯔꯖꯤ ꯑꯣꯏꯇꯥꯔꯒꯗꯤ ꯋꯦꯕꯂꯦꯡꯗ ꯍꯥꯏꯌꯔ ꯋꯦꯕꯂꯦꯡ ꯑꯣꯏꯒꯗꯣꯏꯕ ꯂꯣꯡꯒꯔ ꯋꯦꯕꯂꯦꯡ ꯑꯣꯏꯗꯣꯏꯕ ꯑꯗꯨꯃꯥꯏꯅ ꯇꯧꯗꯅ ꯁꯣꯝꯒꯤ ꯒꯃꯥ ꯔꯦꯁꯤꯗꯁꯨ ꯃꯥꯒꯤ ꯁꯣꯔꯇꯦꯁ ꯋꯦꯕꯂꯦꯡ ꯑꯣꯏ ꯑꯗꯨꯒ ꯍꯥꯏꯌꯦꯁ ꯏꯅꯔꯖꯤ ꯂꯩꯌꯦꯕ ꯁꯨꯃꯥꯏꯅ ꯇꯧꯗꯅ ꯑꯩꯈꯣꯏꯅ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ ꯁꯤꯗ ꯂꯩꯔꯦ ꯔꯦꯗꯤꯑꯣ ꯋꯦꯕꯂꯦꯡ ꯃꯥꯏꯀ꯭ꯔꯣꯋꯦꯚꯁ ꯑꯗꯨꯗꯩ ꯏꯟꯐ꯭ꯔꯥꯔꯦꯗ ꯚꯤꯖꯤꯕꯜ ꯂꯥꯏꯠ ꯑꯜꯇ꯭ꯔꯥꯚꯥꯏꯑꯣꯂꯦꯠ ꯑꯗꯨꯗꯩ ꯑꯦꯛꯁꯔꯦꯁ ꯑꯦꯟ ꯒꯃꯥ ꯔꯦ ꯍꯥꯏꯔꯤꯕꯁꯤꯡ ꯑꯁꯤ ꯉꯁꯥꯏꯒꯤ electromagnetic spectrumꯁꯤꯗ ꯌꯥꯎꯕ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ ꯃꯈꯜꯒꯤ ꯋꯦꯕꯂꯦꯡ ꯑꯃꯁꯨꯡ ꯏꯅꯔꯖꯤ ꯂꯦꯚꯦꯜꯗ ꯑꯩꯈꯣꯏꯅ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ ꯁꯤꯁꯤꯡꯁꯦ ꯑꯩꯈꯣꯏꯅ ꯈꯥꯏꯗꯣꯛꯄ ꯌꯥꯏ ꯑꯗꯨꯒ ꯁꯤꯗ ꯁꯤꯒꯤ ꯃꯅꯨꯡꯗ ꯑꯩꯈꯣꯏꯅ ꯚꯤꯖꯤꯕꯜ ꯂꯥꯏꯠꯅ ꯁꯤꯗ 3 to 8 ꯀꯤ ꯅꯦꯅꯣꯃꯤꯇꯔꯗ ꯂꯩꯕ ꯁꯔꯨꯛꯁꯤꯕꯨ ꯑꯩꯈꯣꯏꯅ ꯚꯤꯖꯤꯕꯜ ꯂꯥꯏꯠ ꯍꯥꯏꯔ ꯈꯪꯅꯩꯑꯕ ꯁꯤꯒꯤ electromagnetic wave exists in a wide range of ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟ ꯂꯩ ꯑꯗꯨꯕꯨ ꯑꯩꯈꯣꯏꯅ ꯃꯤꯠꯅ ꯎꯕ ꯉꯝꯕ ꯖꯦ ꯅꯦꯔꯣ ꯀꯔꯝꯕ ꯐ꯭ꯔꯤꯀ꯭ꯋꯦꯟꯁꯤꯗ ꯂꯩ ꯍꯥꯏꯇꯥꯔꯒꯗꯤ ꯁꯤꯗ ꯃꯈꯥꯗ ꯄꯤꯔꯤꯕ ꯋꯦꯕꯂꯦꯡ 3 to 8 ꯁꯤꯐꯧꯒꯤ ꯃꯅꯨꯡꯗ ꯂꯩꯕ ꯋꯦꯕꯂꯦꯡꯁꯤꯕꯨ ꯑꯩꯈꯣꯏꯅ ꯚꯤꯖꯤꯕꯜ ꯂꯥꯏꯠ ꯍꯥꯏꯔ ꯈꯪꯉꯤ ꯁꯤꯗ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ ꯚꯤꯖꯤꯕꯜ ꯂꯥꯏꯠꯀꯤ ꯃꯅꯨꯡꯗ ꯑꯩꯈꯣꯏꯅ ꯚꯥꯏꯑꯣꯂꯦꯠ ꯏꯟꯗꯤꯒꯣ ꯕ꯭ꯂꯨ ꯒ꯭ꯔꯤꯟ ꯌꯦꯂꯣ ꯑꯣꯔꯦꯟꯖ ꯔꯦꯗ ꯍꯥꯏꯔꯤꯕꯁꯤꯡꯁꯤ ꯑꯩꯈꯣꯏꯅ ꯋꯦꯕꯂꯦꯡ ꯃꯥꯒꯤ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ ꯋꯦꯕꯂꯦꯡꯁꯤꯡꯗ ꯁꯟꯗꯣꯛꯏ ꯈ꯭ꯋꯥꯏꯗꯒꯤ ꯋꯦꯕꯂꯦꯡ ꯈ꯭ꯋꯥꯏꯗꯒꯤ ꯁꯥꯡꯕꯁꯤꯅ ꯚꯥꯏꯑꯣꯂꯦꯠ ꯑꯣꯏꯒꯅꯤ ꯑꯗꯨꯒ ꯅꯦꯠꯀꯤ ꯂꯦꯝ ꯈꯔ ꯂꯩꯔꯦꯀꯣ ꯅꯦꯠꯁꯦ ꯈꯤꯇꯪ ꯑꯩꯒꯤꯗ ꯅꯦꯠꯁꯦ ꯈꯤꯇꯪ ꯅꯨꯡꯉꯥꯏꯇꯕ ꯑꯗꯨꯒꯤ ꯑꯃꯨꯛ ꯇꯠꯂꯝꯃꯦ ꯑꯗꯨꯁꯤꯗ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ ꯃꯥꯒꯤ ꯋꯦꯕ ꯂꯦꯡ ꯇꯣꯉꯥꯟꯕ ꯈ꯭ꯋꯥꯏ ꯆꯥꯎꯕ ꯋꯦꯕ ꯂꯦꯡꯁꯤꯅ ꯚꯥꯏꯑꯣꯂꯦꯠ ꯑꯣꯏꯔꯅꯤ ꯑꯗꯨꯒ ꯈ꯭ꯋꯥꯏꯗꯒꯤ ꯄꯤꯛꯄ ꯋꯦꯕ ꯂꯦꯡꯁꯤꯅ ꯔꯦꯗꯁꯤ ꯑꯣꯏꯔꯅꯤ ꯑꯗꯨꯒ ꯏꯅꯔ ꯋꯦꯕ ꯂꯦꯡ ꯈ꯭ꯋꯥꯏꯗꯒꯤ ꯄꯤꯛꯄꯁꯤꯅ ꯏꯅꯔꯖꯤ가 ꯈ꯭ꯋꯥꯏ ꯋꯥꯡꯉꯅꯤ ꯔꯦꯠꯁꯤꯅ ꯈ꯭ꯋꯥꯏ ꯋꯥꯡꯉꯅꯤ ꯁꯨꯃꯥꯏꯅ ꯁꯨꯝ ꯇꯧꯗꯅ ꯃꯊꯛꯇ ꯀꯥꯈꯠꯂꯒꯅ ꯍꯟꯊꯔꯛꯀꯗꯣꯏꯕ ꯃꯥꯒꯤ ꯏꯅꯔꯖꯤ ꯂꯦꯚꯦꯜ ꯑꯗꯨꯒ ꯋꯦꯕ ꯂꯦꯡꯗꯅ ꯃꯊꯛꯇꯒꯤ ꯚꯥꯏꯑꯣꯂꯦꯠ ꯏꯟꯗꯤꯒꯣ ꯕ꯭ꯂꯨ ꯒ꯭रीन येलो ऑरेंज रेड सुमाइना मागी वैल्यू जे वेब लेंगी वैल्यू जे हेंगल कनेबा देन साउंड वेब को कोई साउंड वेब से साउंड वेब हाई तागदी अखोइना साउंड इनर्जी ओइना चलन मागी अदो अखोइना माजे the primary unit of sound je akhona kai da all hai ta ga decimal ko sound waves na decimal da adu tongan ba magi tam jing lere sida amplitude sidi ngasai du ga manare frequency manare ko sa manana adu sida akhona di ngasai gi asom dana tongan ba magi unit lei wave kidana aduga jigi sound wave tana amplitude tana loudness oirakpa aduga frequency dana pitch oibako there are three frequency ranges in which sound is categorized. Frequency is the number of vibration per second. Dugo ko na frequency wave. Aduga magi frequency je koi sound je sound energy oy lakpa matamda akhoi gi kamaina magi range to gi matung inna akoina ahum thongna sida kaidoi ahanbada audible range ta ko the sound wave between frequency of 20 Hz to 20 kHz is audible to human ears and it is called audible range ko an audible range ko jimaramdi akoigi human ears na ta ngambagi shakti do sigi range 20 Hz to 20 kHz gi manung da range da lei taradi akoi miwe bana ta ngami aduga infrasonic tana sound wave below frequency 20 Hz are called infrasonic and are inaudible to human ears. Sina ngasai less than akoi miwe bana tab ngambagi chigi 20 Hz dagi handagi bajimna akoi infrasonic kawi adu ultrasonic sigi infrasonic range da karam ba jiba jingna tab ngamge haitadi elephant whales rhino haiba jing ji akoi miwe badagi hena tab ngambagi shakti lebe lingduni ko nabi apik pas magi sound tab ngambajing ji elephant whales rhino singba animal makal jingje na tab ngamba heli aduga ultrasonic tana the sound waves with frequency above 20 Hz are called ultrasonic ko above 20 kHz haiba above 20 kHz waragana miyo na tab ngamdabdudi hen gibjingna ultrasonic audible de hen gibjina ultrasonic kawi karam jiwa jingna tab ngami sound je tab ngami hata bats and dolphins communicate through si ultrasonic wave moidi sigi wave makal sound wave sida moidi tab ngameba sumaina tawdana moigi frequency tu matung ina tongan ba sound gi range khaidoi ko ahum thongna sima exam da dung khamjen ba kan na gani tongan sida various properties of sound wave sound waves are longitudinal mechanical waves they need material medium for their generation and propagation ko sound wave ti medium ma darkar le hai and they cannot transverse through vacuum so their velocity in vacuum is zero sound wave ti medium ama darkar le vacuum da di masat pangamde sound wave travel faster in solid than in liquid than in gas haibadi akoina state leibado state of matter da sound je akoina solid oiba posing jida di maje sound je chatpada yam thuna ꯆꯠꯄ ꯉꯝꯃꯤ ꯑꯗꯨꯒ ꯂꯤꯀ꯭ꯋꯤꯗꯇꯩꯁꯨ ꯒ꯭ꯌꯥꯁꯇꯩꯁꯨ ꯃꯥꯅ ꯁꯣꯂꯤꯗꯅ ꯍꯦꯜꯂꯅꯤ ꯑꯗꯨꯒ ꯃꯊꯪꯗ ꯂꯤꯀ꯭ꯋꯤꯗ ꯂꯩꯕ ꯃꯊꯪ ꯒ꯭ꯌꯥꯁꯇ ꯂꯩꯕꯗꯗꯤ ꯑꯃꯨꯛ ꯆꯠꯄ ꯉꯝꯗ꯭ꯔꯦꯕ ꯃꯔꯝꯗꯤ ꯃꯣꯏꯒꯤ ꯄꯥꯔꯇꯤꯀꯜꯁꯤꯡꯗꯣ ꯑꯃꯒ ꯑꯃꯒ ꯂꯟꯊꯣꯛꯅꯔ ꯂꯩꯕꯅ ꯃꯔꯝ ꯑꯣꯏꯔꯀꯥꯟꯗ ꯃꯥꯒꯤ ꯁꯥꯎꯟꯒꯤ ꯋꯦꯕꯇꯣ ꯆꯠꯄ ꯃꯇꯝꯗ ꯃꯥꯒꯤ ꯄ꯭ꯔꯣꯄꯥꯒꯦꯁꯟꯗꯣ ꯉꯝꯗꯦ ꯃꯔꯝꯁꯤꯅ ꯑꯩꯈꯣꯏꯅ ꯁꯥꯎꯟ ꯋꯦꯕꯁꯦ ꯁꯣꯂꯤꯠ ꯑꯣꯏꯕ ꯄꯣꯠꯁꯤꯡꯁꯤꯅ ꯍꯦꯟꯅ ꯃꯄꯨꯡ ꯐꯥꯅ ꯆꯠꯄ ꯉꯝꯃꯦꯕ and optics ko optics ki section da when optics is the branch of physics which deals with the study of behavior and properties of light ko light ka mari lenaba maram da ne do kon optics ar khang nai light is an electromagnetic wave having transverse nature ko light travels in straight line gi magi properties it bends or split into part at the interface between two different media ko koina tongan ba medium posak ani tongan ba magi properties manadaba posak ani medium ani thengnaba matamda maje bend tauba or split into parts tawrakanda akogi light se chatle hare it follows the part in a medium where refractive index changes magi magi tongan ba lay property ama tuki mana reflect ꯂꯩꯔꯨꯔꯤꯕ ꯆꯦꯟꯖ ꯇꯧꯔꯛꯏꯕ ꯃꯦꯗꯤꯌꯝꯗꯨꯒꯤ ꯃꯥꯒꯤ ꯔꯤꯐ꯭ꯔꯥꯛꯇꯤꯞ ꯏꯟꯗꯦꯛꯁꯇꯨꯒꯤ ꯃꯇꯨꯡ ꯏꯟꯅ ꯃꯥꯒꯤ ꯄꯥꯔꯠꯇꯨ ꯀꯔꯣꯝ ꯅꯥꯀꯟꯗ ꯆꯠꯄꯒꯦ ꯍꯥꯏꯕꯗꯨ ꯑꯃꯨꯛ ꯍꯟꯗꯣꯔꯛꯄ꯭ꯔꯥ ꯅꯠꯇ꯭ꯔꯒꯅ ꯑꯃꯨꯛ ꯃꯅꯨꯡꯗ ꯐꯥꯎꯔ ꯆꯠꯄ ꯉꯝꯕ꯭ꯔꯥ ꯑꯗꯨꯃꯥꯏꯒꯤ mediumꯗꯨꯒꯤ refractive index की मखा पोली it may be reflected absorbed or transmitted ko any medium amadagi ama chapa matamda medium du da thiengu matamda mado thaktorakpa natragana chupsangiba light sing du pulap chupsangiba natragana mu transmitted tawpa transmit tawthokiba atopada mu transmit tawkiba lei aduga akhona sida reflection of light haita agadi bounce back of light at any interface between two different media ꯉꯁꯥꯏꯒꯤ ꯇꯣꯉꯥꯟꯕ ꯃꯦꯗꯤꯌꯝ ꯑꯅꯤ ꯊꯦꯡꯅꯕ ꯃꯇꯝꯗ ꯃꯥꯗꯨꯅ ꯂꯥꯏꯠꯇꯨ bounce back ꯇꯧꯔꯛꯑꯒꯗꯤ ꯑꯩꯈꯣꯏꯅ ꯃꯗꯨꯕꯨ reflection of light ꯀꯧꯏ ꯁꯤꯒ ꯃꯔꯤ ꯂꯩꯅꯕꯗ loss of reflection sigi the incident and the reflected ray and the normal are lies in the same plane ko sida makha piriba si somgi jina mirror amada sidagi point p dagi laiba light se point q sida amuk thaktokiba tu bounce pulap magi light sing do amuhana thaktokiba samanaba magi angle da hai tare ko adubu na khona sigi loss of reflection sigi ne loss of reflection ile haigani aduga si refraction of light haigana when a light rays passes from one transparent medium to another it gets deviated from its original path while crossing the interface of two media the phenomena is called refraction of bending of light from the original part while passing through the medium is the another is called refraction ko ngasagi sida medium 1 leire medium 1 leire aduga sida medium 2 leire haiba medium ani je magi properties khenai adudagi de akhon sida incident ray and jangai light ki a beam of light se ngasagi sigi interface hai tari medium ani sigi thengnabam jineba sidagi jangai light se ngasagi sida akhon transparent oibanina phau matamda magje akhona thaktuwa kanda ngasai mana chatkadoba part dagi thaktuwa kanda reflect tonganba reflected angle tonganba amada maje amuk chatleba sigi thawong tubu akhona refraction hai khangneba when light travels from a rear medium to denser medium it bends towards the normal sida akhona kaigba sigi medium ani je sina medium ji am hena kung daba medium oiba aduga somdana yam hena kung boi taragadi maje normal onda changjilagani angle je smani straight oina chakadabdagi straight oina chakadabdi som angle ji oina thaijilagani ba aduga when the light travels from denser media medium 1 sina kayma denser oiba medium 2 sina kayma rear haibadi khara pathaba medium oitagadi majina ngasai sida texel bi muta ngasai normal dagi ꯅꯣꯔꯃꯦꯜꯗꯨꯗꯒꯤ ꯊꯛꯇꯣꯛꯈꯤꯕ ꯁꯨꯃꯥꯏꯅ ꯁꯤꯗ ꯂꯥꯛꯀꯗꯧꯕ ꯂꯥꯏꯟꯗꯨꯗꯒꯤ ꯊꯛꯇꯣꯛꯈꯤꯕꯀꯣ ꯁꯨꯃꯥꯏꯅ ꯃꯥꯒꯤ ꯔꯤꯐ꯭ꯔꯥꯛꯁꯟꯒꯤ ꯄ꯭ꯔꯣꯄꯔꯇꯤꯁꯤꯗ ꯁꯨꯃꯥꯏꯅ ꯂꯩꯅꯤ. It happens when light travels through the medium that has a changing index of refraction. Refraction occurs due to a change in the speed of light as it enters a different media. Masai media ani tu property khenabna maram oirkanda magi refraction jo thoini. Laws of refraction: the incident ray, the refracted ray, and the normal lies in the same plane ko. Aduga the ratio of the inclined angle to the reflected angle is a constant for the pair of media and is equal to the refractive index of that media. Sida layriba refracted incident ki sida piriba angle siga refracted angle siga ma ani je chap manana laigani haiba. Aduga akoina loss of refraction je maming amas lay Snell's law haiga jo akoina khangnai. And surface akoina light na travel tauba matamda ngasagi any form of medium ama lanba matamda magi angle reflect tauba natragana amu kaino da medium do pass tawrakanda amu reflected ray wen sakiba sigi bajingje akoina sigi lay aduga akoina sigi mirror spherical mirror or any plane mirror hai taragadi akoina plane mirror dadi magi incident ray je loinabak reflect tawrakaneba inversely hai tare aduga sigi refraction sigi spherical mirror sidadi adugi value properties to source tawroiko sida spherical mirror whose refractive surface is curved inwards that is called convex mirror ko asagi plane mirror na akoi chamjama mirror du di magi di total tagi bado inversely chamana na form tawrakaneba magi image to form tawrakpa matamda aduga sigi spherical mirror dadi tonga magi sida kemba magi face to kai gedauba cup inwards oirgana magi do concave mirror tawbe aduga cup outward oirgana magi convex mirror ko chimba mirror makhal akoina kai kai desina ya tari convex mirror sina torch kumba searchlight and vehicle headlights to get powerful parallel beam of light ko aduga akoina use of convex mirror dana rear view oiba in vehicle akoina magi tariba image to picture na taba amasung kedawa sida they always give an erect achumba image form tawrakani aduga do diminish pixel lakaneba image ti pixel lakwa aduga erect oin taba. Also they have a wider field of view as they are curved outwards ko sigi convex mirror gi sinabam aduga next na lens is an optical device based on phenomena of refraction ko refraction gi phenomena do thokpa makhal gi optical device tu bo khona lens har khangnai adu sida a lens is a transparent medium bound by two refractive surface ko lens haibje transparent oiba makhal gi medium ani punjalakanda sema makhal mani it can produce two types of rays converging and diverging rays ko punjalanba converging id amaga ray jingdubu akoina medium amada lakpa matamda magi angle jing do jaga khara da punjalanba duna converging aduga diverging rays hairgana laiba medium amadagi laiba magi mangal jing do atopa jing da thakduhan badumna diverging rays ko aduga tam related to lens akoina lens lainaba matamda sinaba tam jing sida lere center of curvature radius of curvature aduga principal axis ko sidi yam henna maru oidabran khalle exam ga mari lainaba dati ko aduga sida akoina power of lens power of lens se akhona ngasai optical device ni mangonda akhona power hapa yaiba reciprocal the focal length measured in meters ngasai converging ray natra diverging ray dubu akhona adjust taunabagi damakta meters ta adjust taunabagi damakta semiba adungbo power dubu akhona power of lens kaweba. The unit of power of lens is meter per meter inverse, which is called diopter, indicated by D. अखोना power lens से कहीं ओले है ताकि diopter diopter को मागी symbol ना D ना अदुगा अखोना सिदा defects of vision and their correction स्माइल तो उधर सिगी lens साइड अखोना मियो बगी mid सिदा कहीं बब normal eye नत्तबा अखोना लाम पोषक सिंह उब नॉर्मल होइना उब ngamdabdo adum kanda अखोना तोंगान तोंगान lens मखल सिंह सिनाई को अदमो सिदाजु सिदा there are mainly three common refractive defect of vision. This defect can be corrected by the use of suitable spherical lenses ko. These are myopia or nearsightedness. Myopia is also known as nearsightedness. A person with myopia can see near objects clearly but cannot see distant objects distinctly. अरापद लेब पोचिंग उ ngamdaba haitare anakpati ngamba arapa jingana sijinde akoina this defect can be corrected by using a convex lens of suitable porokong sai mongon da adjust tawrakanda suitable magi focal length do sema kanda mi du ga janan na sema kanda magi ubai shakti do lehen bangam ngamale basigi जेसिनर का कन्वेक्स लेंस जेसिनर को अदो hypermetropia na or farsightedness sina ngasagi opposite arapa pona ubang ngamba aduga anapa pona ubang ngam dabado sijina khoina hypermetropia ko sigmugi makal gi laina sina aduga presbyopia sina the power of accommodation of the eye usually decrease with aging ko ahan ho chala bajing da animak sigi na abado animak singe animak sagi arapa ju udaba anepaju udaba animaki mitta sok podbu khona sigi presbyopia ka web ko. It arises due to the gradual weakness of the ciliary muscles and diminishing flexibility of the eye lens. Sometimes a person may suffer from both see animal to na OBI. Such people often require bifocal length. Focal length ani yawa ngasagi moin sinariba specs natragana lens da sigi focal length ani yawa je sinar kanda sigi presbyopia je akoina layang ngame basi magi vision du uhan ngame ko and sida ko nang sagi light na travel to matam da thon ba to makhal ki phenomenology reflection ja ko na mamin kaya total internal reflection ko when light is reflected into a denser medium from an ngasai refraction ki part amani siju aduga ke wasidana when a light is reflected from a denser medium from an interface to a denser and rarer medium and there is no refracted light, the phenomena is known as a total internal reflection ko sangai ba light sing du ngasai denser medium dagi rarer medium da chatpa matam da magi tholaiba light to magi ngasai gi thokado reflection gi thokado light dagi opposite ta tongana chatki na sigi phenomena total internet reflection thokpa na haiduneba. Sida there are two initial conditions for the total internet reflection layer. The light should travel from denser medium to rarer medium ko. Aduga the angle of incidence in the denser medium should be greater than the critical angle ko. Aduga siga mari leinaba ngasai refraction and the total internet reflection siga mari leinaba natural phenomena akoina uba makalgi phenomena jing le rainbow ji akoina rainbow are an incredible natural display caused by the combined effects of refraction internet refraction reflection and dispersal of sunlight through air raindrops ko si phenomena jing de to kanda akoina si rainbow habi ubang sel drop as a tiny prism ko koi prism the light hazila kanda koi seven color figure thok do adugi maungda rainbow da akoina seven colors u phang je sigi refraction internet reflection jing je thok pe ne sigi phenomena je aduga mirage hairgana on a hot road natragana any surface ama da akoina maje heat up nungsai mangalsina temperature ji sagala kan maduda da akoina mangalsina fujanba matamda akoina tonganba masak ama creating the illusion of water ising leiba manba sigba ta ki phenomena jina mirage kawe sina example of atmospheric refraction ko thol libjina refraction na thon baneba mirage. The blue sky and the red sunset or sunrise call due to the scattering of light shorter wavelengths like the ngasai akoina light che white che composition je magi seven colors visible the seven colors yabudo adu dugi adun maram orakanda thon baneba sigi blue sky and red sunset che sida shorter wavelengths like blue na scatter more wavelength atenbasina hena sandoe adun akoina giving the sky its color ko akoina nungdini matamda sigi blue sky is blue and uba during sunset the light passes through more atmosphere power la ko matamda tuan ba magi longer wavelength oibna maram kanda sigi shorter my energy do high oiba energy na sang satpa ngamani low oiba energy natragana low oiba energy na khajtangda magi light keno do mangan do khajtangda pitole horani aduna marna high oiba energy duna swana allowing red and orange to dominate ko sina atmosphere sang na phawla agadi adugi matam dudana hoina red natraga orange ko singuma color jina ul koi atmosphere ji uba sky ji uba duna maram orakanda sunset ji da red oiba adudagi de amu shorter wavelength oiba matam nungsa sai matam dana blue sky to pasi jine kun uba phange duga optical instruments sing da hoina kan sida p region microscope ko magi kai sina ata agadi use multiple convex lens to magnify small specimens enabling breakthroughs in biology and medicine da ko magi sinabam jadu telescope agna use concave lens mirrored and lenses to observe far off stars and galaxies advancing our understanding of space ko telescope sinaba lens na concave lens aduga microscope sinaba na convex lens adudagi se hoi cameras adudagi di projectors high lasers high bising jo koina lens makal sinar kanda magi tongan ba makhalgi sinabam pi ko aduga sida makada pi leiba topics na some physics related inventions and discovery ko sije simai topic ti tongana leitraga jo koina simana invention and discoveries ko chahi gi oina leiba aduga physics ka related oiba makhalgi inventions and discoveries ni ko sije adumai material sara kanda dum yengbe arni sijima sipa pugo do saru oibani na ꯑꯗꯨꯒ ꯁꯤꯗꯅ ꯂꯩꯔꯤꯁꯤꯅ important scientific instruments ꯀꯣ scientific instruments ꯃꯌꯥꯝ ꯃꯥꯒꯤ ꯑꯗꯨꯒ ꯃꯥꯒꯤ uses ꯁꯤꯁꯦ ꯃꯃꯥꯡ ꯀꯣꯏꯁꯟꯗ ꯑꯗꯨꯝ ꯍꯪꯈ꯭ꯔꯦ 2000 ꯍꯣꯔꯦꯟ ꯀꯣꯏꯁꯟ ꯅꯩꯅꯕꯗ ꯌꯦꯡꯉꯁꯤꯀꯣ ꯁꯤꯒꯤ important scientific instrumentsꯤꯡꯁꯤꯒ ꯃꯔꯤ ꯂꯩꯅꯕ ꯀꯣꯏꯁꯟꯁꯤꯡ ꯍꯥꯏꯇꯥꯔꯦ Okay. Sida laiba question number 25 2025 da hamba question which of the following physical processes is responsible for the blue color of the sky sky je blue color oibagi magi physical process to karam responsible oy haibane the absorption of solar radiation by air molecules si oigadra natragna total internet reflection of solar radiations by clouds ko aduga scattering of solar radiation by air molecules and particles or marisubada dispersion of solar radiation by clouds ko sigi mari jigmong da karamba sumi hai tagadi option number 3 for scattering of solar radiation by air molecules and particles ko अखोई एटमॉस्फेयर लेबा मॉलिक्यूल्स एंड पार्टिकल्स इन स्केटर तौबदगी ngसाई अखोई ओनली वेवलेंथ शॉर्टर वेवलेंथ दुना फाउजलप ngambado aduna maram orakanda akhona sky je blue oina leini adu question number 24 the arrange the following radiation in the increasing order of their energy go sida infrared ray UV rays visible rays express microwave radiation ko seeing the following radiation increasing of their energy sina sagi kaino to yemba yai okay diagram da sida akoina energy higher energy di akoina gamma rays wavelength atenba natragan high frequency level jingsidana high frequency level jingsidana higher energy laini aduga low frequency level jingna lower energy laineba sigi matungina low dagi na low energy radio na low energy warni aduga microwave infrared adudagi visible range ultraviolet adudagi x-rays gamma ray ko aduga sumsom nakan right ta chalagana energy je higher way khalakpa aduga left ta chalagana decrease tarokko my energy level je to question da ngamisna energy level gi matungina magi increasing order se amount energy khwayam dabduna kana warni dudi microwave radiation ware lagi matang infrared ray option number D ko infrared ray matang da visible range matang da UV radiation matang da x-rays ko sumai tawdana option D is money aduga ahum suba question da a shopkeeper needs to measure the purity of milk which instrument he should use sida tongan basida hygrometer ko lactometer and manometer and viscometer ko sumai tongan magi instrument jing pirasi manung sida akoina milk se pure mai ising yali yandi khangna binum karam khulai on gani haita de akoina lactometer haibu khulai sinar kanda akoina sangongi purity on be ai ko okay haiba jingje ngasigi topic akoina physics ta nainari ba topic singjiga yamba saruk sida cover tawre aduga sida watloba adum khare yawe akoina period je nongmada haibadi science ki har kanda portion je chawbanina akoina sida cover tawdaba khare su yawe aduga akoina hena paning khangning ba leraga akoina NCERT ki larik sing adum khaga yengba yai ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ ꯑꯇꯣꯞ ꯑꯇꯣꯞꯄ ꯁꯣꯔꯁꯇꯒꯤꯀꯣ ꯁꯤꯒ ꯔꯤꯂꯦꯇꯦꯠ ꯑꯣꯏꯕ ꯇꯣꯄꯤꯛꯁꯤꯡꯗ ꯍꯥꯏꯇꯥꯔꯦꯀꯣ ꯑꯣꯀꯦ ꯉꯁꯤꯒꯤꯗꯤ ꯁꯤꯗ ꯂꯣꯏꯔꯦ ꯐꯤꯖꯤꯛꯁꯀꯤ ꯍꯌꯦꯡꯗꯒꯤ ꯑꯃꯨꯛ ꯑꯩꯈꯣꯏꯒꯤ ꯊꯥꯔꯠ ꯗꯦꯗꯒꯤ ꯑꯩꯈꯣꯏꯅ ꯕꯥꯏꯑꯣꯂꯣꯖꯤꯒꯤ ꯁꯕꯖꯦꯛ ꯑꯣꯏꯅ ꯅꯩꯅꯔꯅꯤ ꯍꯌꯦꯡꯗꯒꯤꯗꯤ ꯑꯣꯀꯦ ꯉꯁꯤꯒꯤꯗꯤ ꯑꯗꯨ ꯁꯤꯗ ꯀ꯭ꯂꯥꯁ ꯂꯣꯏꯁꯜꯂꯁꯤꯀꯣ ꯑꯗꯨꯗꯤ ꯃꯌꯥꯝ ꯊꯦꯡꯛ ꯌꯨ